Hello, viewers. Here we have another interesting question. Solve the equation log to base 3 of 2 cosine of 2x equals to 1 over 2. So this is a question that requires us to apply our knowledge of logarithm equations and trigonometry equation. So here, what can we do? If you look at this question, we need to take what? We're looking for the solution. So here, the first thing we need to do, since this is a logarithmic equation, we need to be sure for every value of x we are going to take that this is going to be positive. Because remember, the domain of a logarithmic function, it's only from 0 to infinity. It has to be positive. All right, so let's start by changing these logarithmic to exponential equations. So this is just going to be 2 cosine of 2x is going to be 3 raised to power what? Half. And remember, if we have log to base a of x is equals to what? Y, it means that x is equals to a to power y. So that is what we just apply here. So 3 to power half. Then this becomes what? Cosine of 2x is going to be what? This is 3 to power half, which is just 3 over 2, right? Okay, so now this is cosine. So cosine is what? It's positive in the first and in the what? In the fourth quadrant. Okay, so here we can get what is our, what I usually call maybe like x star, which is always an angle in the what? An angle in the first quadrant. So it's an angle in the first quadrant, but the cosine of it has to be what? Root 3 by 2. So root 3 by 2 has to be cosine of 30, right? So it means this is going to be pi by what? By 6. All right. But now let's deal with when we are in the first quadrant. If we're in the first quadrant, we know our angle is going to be the same thing as our x star. But what is our angle here? In this case, it is 2x. So we'll have 2x is equals to what? Pi by what? By 6. Then we can add the general term, which is the coterminal, to n pi, or the period, right? Okay, so here in the second part here it's when you are in quadrant number 4. In quadrant number 4, we'll have 2x that's equals to what? This is going to be what? 2 pi minus what's now? This one, which is pi over 6, right? Then we're going to add 2n pi. So 2 pi minus pi over 6 is going to be 11 pi. So let's just minimize space. And we can write 11 pi by 6. So from here, I can get what is x. So x here is going to what? Or divide both sides by what? By 2, or multiply by half. This is just going to be pi by 12, right? Plus what? Plus n pi. And this is going to be x is equals to what? 11 pi by also what? By 12 plus what? N pi. All right. So Now let's get our x has to be in where? Our x has to be between 0 and 2 pi. So let's see. Now if you take n to be 0, what do you get? From here, we're going to get pi over 12. From the second part here, we're going to get 11 pi by 12, right? Okay. So what can we do here? Now, let's take n to be what? N to be 1. If you take n to be 1, in this case, what do we have? Here we'll have what? Pi by 12 plus pi, which is the same thing as what? 12 pi by 12, right? So that will be 13 pi by 12. Okay. Then if you put pi here, I mean, we're putting n equals to 1 in the second part, we're going to have 11 pi by 12 plus what? Let's say pi, which we can write as 12 pi by 12. So what do we have there? It's about 23 pi by 12. Okay, I think this is the best we can take. We cannot take n is equals to 2, right? Now we cannot take n is equals to 2 because if you take n equals to 2, you will be outside the range 0 to 2 pi. All right. All right. So now we can finalize that our solution set for this problem, it's just pi over 12, 11 pi over 12, 13 pi over 12, and 23 pi over 12. Now, just how are we sure? Remember earlier I talked about making sure that whatever you get here, it's positive. Yeah, that's true because here we already said that what cosine 2x is what? Is either in the first quadrant or in the fourth quadrant. And in the first or in the fourth, we know that the cosine, the output here is going to be positive. And all these values we got are actually from this using the first and the fourth quadrant, right? But just to be sure, you can check. For example, here, remember these are the values of x, right? These are the values of x. So you can check, you want to test, is 2x, is it in the first quadrant or in the fourth quadrant? Because if it's in the first quadrant or fourth quadrant, we are sure that the output is going to be positive, right? So for example, if you take x to be pi over 12, remember pi over 12 is part of the solution set. So what is 2x? 2x is just going to be pi over 6. And we're sure pi over 6 is in what? Is in the first quadrant. So its cosine is going to be positive. If you multiply by 2, it's still going to be positive. So the logarithm to base 3 is well defined. And you can do that for all the values you have here. For example, if you try for this one, what is x in this case? This is 13 pi by what? By 12. By the time you multiply by 2, so 2x is going to be 13 pi by what? 13 pi by 6 by 6. And what is 13 pi by 6 is in which quadrant? I think this is going to be in also in the first quadrant, because 13 pi, you can convert it to degree to C. This is 13 by 6 times what? Pi. You multiply by 180 divided by pi. So pi will go with pi. And you just have 13 times what? 180 divided by 6. So 6 here is what? Is 3. So we're left with 13 times 30, which should give us 390, right? But 390 is what is bigger than 360. So by the time you remove 360, you will see that it's in quadrant what? Is in quadrant 1 as well. So you can do that for all the four values. They're either in the first quadrant or in the fourth quadrant. So we don't have any, we don't need to worry. It means that the output here, we are very sure that the logarithm to base 3 will be well defined, because everything coming from here is going to be either in the first or in the fourth quadrant. All right. So this is the solution set for this problem. Thank you for watching.